Hi everyone, today I'm back with another video. Today we are going to see something very interesting, which is a part of integral calculus. uh, that's area under the under the curves. Okay, this concept is very important in many curriculums, like in the IBDP, in the Cambridge. You get such type of questions. Today we are going to see one of the most interesting questions. Okay, uh, so let's start. Okay, we have two different functions here in the question. Okay, so one is y equals to sine pi x, and the another one is y equals to x cube minus 4x. For your knowledge, just I'm showing you where this function is actually. This is y equals to sine pi x. This is the function, and the one which is below the x-axis, you can see clearly that's y equals to x cube minus 4x. Okay. Now they are, what they are doing actually. Y equal to x cube minus 4x and y equals to sine pi x. Both of them together, they are trying to uh, they are together making this region R. So the region R is bounded by two different curves. You can see clearly in the picture. One is above, you can see y equal to sine pi x, and the region y equal to x cube minus 4x is going to cover the below part of region R. Okay, so how are we going to solve this question? How are you We have to find the area between this. Okay, so this concept is quite simple. What actually the rule says is, if there are two different functions, let's say f of x and g of x, if they together combined together, if they are forming a region R. Okay, they are together forming a region R, then the region formed by them would be integration f of x, the difference of these two functions, uh, which are forming the region, and the limits will be applied from b to a, whatever the limits, I mean, it's given in the question. Okay, similarly we have two different function in this question. Okay, let me consider one of the functions as f of x, let's say, uh, equals to sine pi x, and I have another one, g of x equals to x cube minus 4x. I have two different functions. Okay, so I'm going to find the region for this. So what I'm going to do here, it's very simple. I'm going to apply the sine pi x minus, okay, this is the first function minus the second function together, which is who are going to form the region R. Okay, and the limit I am going to take is from, you can see clearly this region R. If you take with respect to x-axis, you can see the domain is from 2 to 0, isn't it? It's not exceeding 2 and 2. It's between 0 and 2, so I have to take the limits as 2 to 0. Okay, so what should be the next step? Now I have to integrate this. All you know is, you should know this formula. Okay, what is that? Integration of sine x. Now integration of sine x with respect to x is obviously, integration of sine x is minus cos x, plus c, isn't it? But then you don't have sine x, you have sine pi x. Okay, so according to the rule, what we have, the integration of sine kx dot dx would be minus cos x upon k, isn't it? Plus c. Okay. Uh, Now what I'm going to do here? Now I'm going to replace that. I'm you going to use that formula here. Now integration of sine pi x would be integration of, I should write here kx. Okay. Integration of uh, sine pi x would be minus cos pi x upon pi. Now minus, now you can see integration of x cube. Integration of x cube is x power 4 upon 4, minus integration of 4x is 4 is just a constant, so x square upon 2. Okay, it's between, I have to take between 2 to 0, isn't it? uh, Before we give the inputs to this, before we substitute this upper and lower bounds 2 and 0 in this, we will try to simplify this more. 4 upon 2 is 2, isn't it? uh, this one you have to keep in brackets. Okay, yeah. So now I'm going to substitute 2 as a, now I'm going to use the rule what we have in integrations. Okay, first I have to put the upper limit in this. Okay, let's see what happens. Minus cos 2 pi upon pi minus 2 power 4 upon 4 minus 2 square. Okay, uh, this is the first thing I have finished, isn't it? And then now minus, now I have to substitute the lower limit 0. So this is going to be minus cos 0 upon pi, isn't it? Then minus 0 power 4 upon 4 minus 2 times 0 square, isn't it? And then you got this one. Okay, now you have this one now. uh, Now you can see clearly, now the question became quite easier to understand, isn't it? Now when you substitute x is equals to 2 in this, what I am going to get, this would be, if you put in calculator, minus cos 2 pi upon pi, it's negative 1 or pi minus, uh, if you solve this one, I think what are you going to get here, like this, 2 power 4 upon 4 minus 2 times, if you 2 times 2 square here, it's going to be, it's going to be negative 4, isn't it? Yeah. So negative times negative, you can do positive, everything can put in calculator, I'm doing it manually as of now. Okay, and here in the second case, now this is quite easier, the second case is quite easier here. Minus cos 0 upon pi, so it would be minus 1 upon pi, isn't it? Minus. Anyway, this is going to be the 0, isn't it? Yeah. So if you look here, minus 1 upon pi, minus times minus is plus, and then you have minus into minus is plus 1 upon pi, and this get cancelled. You got the region R as 4. So finally, we got the region. The shaded region R is equals to 4, isn't it? So the final answer would be 4 now. Now the question number B is going to be quite interesting. Okay, this is not going to be easy one. Okay, uh, the horizontal line y equals to negative 2 splits the region R. So this is going to be very interesting now. Uh, the horizontal line y equals to negative 2 splits the region R into two parts. So what I do is here, I'm going to split this region below the x-axis, not exactly below the x-axis, obviously. I won't use the terminology. What I'm going to do is, the horizontal, I'm going to draw a horizontal line y equals to negative 2. This is the horizontal line y equals to minus 2, if you can see, right? Yeah. So now you have got this line y equals to minus 2. uh, Split the region R into two parts. Region R, obviously it's splitting into two parts, not equal, the two different parts. You can see one of the part is above, isn't it? And one of the part is below, below the y equals to minus 2. The question is write, but they want you to write, but do not evaluate. They don't want you to find anything. They don't want you to solve completely. Okay, right? But do not evaluate an integral expression for the area of the part of R that is below this horizontal line. So according to the given data what we are having right now, okay, what we are going to do is, first let's find this two intersection points. Okay, the graph, this line y equals to negative 2, and and this one, what do we call this? Y equals to x cube minus 4x. They are going to intersect at two distinct points. Let's say point B and point A. Okay, I can say any, I can give any name to it. I can even say it as x1 and x2. That won't be a problem. Okay, so to find B and A, I'm not really working on it because he clearly says do not evaluate. Okay, if I suppose if I just want to evaluate, what I am going to do is, since y equal to x cube minus 4x and y equals to negative 2, they are going to intersect at B and A. I'm going to write those two equations here for the question number B. Okay, so for the question number B, y equals to x cube minus 4x and y equals to negative 2. These are the uh, I say the equations, okay, which are going to be useful now. Okay, which are going to form which are going to by which we can find the points B and A, but we are not interested in evaluating it. Okay, just if you want, if you want to evaluate it, just you can equate them. X cube minus 4x equals to negative 2, and then x cube minus 4x plus 2 equals to 0. Okay, now what happens, since this is a cubic equations, you are going to get uh, three different intersections, isn't it? Three intersections, because you are going to, because this is going to give the input three different inputs. But then I'm not interested in finding the intersections, because the clearly the question says do not evaluate it. But I just say that I don't care about how many values I'm going to get from x, but just I have to note that is I should make sure that the value of x should be between 2 to 0, because any point B or A, at any point B and A, you can clearly see uh, there will be an x coordinate and the y coordinate, x coordinate and the y coordinate. So the x coordinate will be x1 and x2. This both will always lie between 2 and 1, right? So I just have to say that, okay, consider consider any two solutions, uh, x1 comma x2, but they should be between 0 and 2, isn't it? That makes sense, but I'm not interested in finding that. Okay, exactly what they are. Okay, but I need x1 and x2 for sure to proceed with this question. Now let's say x1 and x2 are the points on the graph. Okay, let's say x1 and x2 are the two x coordinates, at the intersections, at the two different intersection. I'm not interested in y, because x1 and x2 are enough. Okay, now I am going to define this region this new region which they have asked in the question number B. Okay, how I'm going to do it's very simple. Again, I'm going to use the same formula. This the region, this red region which I have shaded, you can clearly see it's made up of two different equations. One is y equals to negative 2. It's bounded with two different equations. Y equals to negative 2. The another one is y equals to x cube minus 4x. But my limit shouldn't be from 2 to 0. My limit should be from x2 to x1. Did you get my point? So what I'm going to do is I'm going to use this concept here. Okay. So uh, the region, the, the required region for the question number B will be equals to x2 to x1, right? I don't know what exactly those points are, as they have asked that we shouldn't evaluate them. Okay, according to the question. So x2 to x1. So what are the two different equations? Y equals to negative 2 and this one. So I have to subtract them, isn't it? That's what I have told you. That's what I have taught you in the question number A. So I'm going to subtract them. So negative 2 is the first equation, and the second equation is x cube minus 4x with respect to dx. Okay. So by solving these two different equations, sorry, two I mean the by solving this integral uh, x2 to x1 and minus 2 minus of x cube minus 4x dot dx, we are going to get some value from this. Okay, but we are not interested in doing it because we don't know what is x2 and x1. We can find x2 and x1 from this, but I didn't found because this question says that they just need you, they just want you to find the expression for this. Okay, so this is how you have to work on these questions. These are really good questions. Okay, we will in the next video we will try to I'll try to get more interesting question on the same topic, area under the curve. Okay, so uh, uh, if you have anything to ask, regarding this topic, you can just text me there in the chat, in the comment box. Okay, so thank you for watching.